This audiobook of the original America Burning was produced by the firefighter podcast Combustible. More details on this project can be found online at www.combustiblethepodcast.com. The audio for this recording is consistent with all copyright rights and permissions associated with America Burning and is not affiliated with or endorsed in any way by the federal government or the U.S. Fire Administration. Chapter 18. Research for Tomorrow's Fire Problem. In both the public and private sectors, the nation spends about $105 million annually on research and development related to fire. See Appendix 7. It would be difficult to define an adequate level of investment against which this figure could be compared. But the evidence marshaled earlier in this report of laggard progress in the technology of firefighting, the treatment of burn and smoke victims, and fire protection of the built environment suggests that the nation is seriously underinvesting in fire-related research. Much of the research is devoted to narrow and short-term goals. Industrial research and development, for example, is largely devoted to ensuring that materials and products meet existing codes rather than more ambitious standards of fire safety. Of the $27 million spent on fire research and development by the federal government, about $18 million is directed to the specific missions of the sponsoring agencies. For example, in the Atomic Energy Commission, to the prevention and control of fires in nuclear reactor facilities. Comparatively, little has been done in the realm of basic research and other research in which, if a technological improvement is a possibility, it is a long-term payoff. As far back as 1959, the Committee on Fire Research of the National Research Council noted a dearth of basic research directed toward a fundamental understanding of the phenomena of ignition, fire growth, and fire spread. The committee recommended a national program emphasizing those areas not adequately covered by current efforts of military and civil agencies. During the 1960s, most of the basic research on fire pertained to forest fires, since the forest environment was easier to deal with and properly preceded attention to the more complex environment of urban fires. By 1969, the Committee on Fire Research was able to report small but significant progress in basic fire research. In the mid-1960s, research interest in the built environment was spurred by new federal laws dealing with fire safety, in particular with certain fabrics and the materials in aircraft interiors. An expanding role for the federal government was defined when the Fire Research and Safety Act of 1968 authorized the National Bureau of Standards to undertake a more comprehensive research program. When the National Science Foundation established its Research Applied to National Needs program in 1971, it opened the way to more extensive fire research. Some notable achievements have been made. For example, some of the reactions that take place in a flame are now understood, which opens the way to understanding how the addition of chemicals might inhibit flames. The basic mechanisms of heat radiation are understood almost to the point where the distances at which other fuels in a room will ignite by the radiative energy from a fire can be predicted. In the realm of technological improvements, additives for water have been developed which reduce friction in a hose. Other additives make water light, so that it floats on top of liquid fuels and smothers flames. Some areas for exploration. There is much to be done in the broad field of fire research. We have indicated important areas for specific research throughout the report. One basic need is to strengthen this grounding of knowledge about fire in a body of scientific and engineering theory, so that real-world problems can be dealt with through predictive analyses. The development and testing of new materials and assemblies, the teaching of fire protection, the creation of new architectural designs, the engineering design of more effective fire control systems, and the development of fire prevention programs could be greatly expanded and improved if more fundamental understanding of fire behavior were available. Human behavior. Because so many fires are due to human carelessness, and because so many people react counterproductively when a fire occurs, the Commission has placed great emphasis on education as a mean of reducing the nation's fire losses. But carelessness blankets a range of behavior from relative innocence and helplessness to subconscious attention-getting or self-destructiveness. Effective educational efforts will depend on a much firmer knowledge of why people cause fires than now exists. Moreover, those efforts will require studies of what kinds of fire safety messages work. That is, which kinds of presentations alter human behavior to reduce fire accidents and their consequences, rather than cause citizens to tune out, as can happen if the messages are too scary, or blunt their sensitivity through too much repetition. Likewise, arson covers behavior from pyromania to fire setting motivated by greed. Better understanding of this range of behavior would greatly aid the apprehension of arsonists, the search for safeguards against arson, and the search for alternatives. That is, less destructive outlets for the mentally sick arsonist, and attractive economic alternatives for those who deliberately set fire to their own property. Fire dynamics. To the extent that materials in the built environment are controlled at all, they are controlled by voluntary standards and building codes, each of which can be no better than the test methods specified for measuring fire performance. Unfortunately, present test methods often yield numbers that tell little more than how materials or structures behave in idealized test configurations. Actual fire performance in a building depends critically on such factors as physical layout, interactions between walls, floors, and ceilings, fuel loads, and the presence of complicating components such as air conditioning ducts. Thus, there is a need for research toward the development of test methods that more accurately predict real-world fire performance. Smoke and toxic gases. The physiological effects of smoke inhalation and tolerance limits are not known adequately. Neither is much known about the chemical nature of combustion products, nor how smoke and gases are influenced by combustion conditions, such as temperature and turbulence. Smoke and toxic gases are important hazards, and a better understanding of their chemical and physical nature, how they are generated, how they move with lethal effect for great distances through a building, and their physiological effects, would provide a foundation of knowledge needed for the development of test methods, standards, and countermeasures. Automatic detection. Of basic importance is finding the best harbinger of fire. 3 considerations enter in: reliable early warning, low cost, and a triggering mechanism that will not be activated by causes other than fire. The best early warning detectors now on the market use optical detectors to sense smoke or electrical means to detect the particulate products of combustion. Largely as a result of contracts from the National Aeronautics and Space Administration, a number of industrial and government laboratories are investigating carbon monoxide detection by spectroscopic techniques. Another possible approach is detection of microscopic particulates, called aerosols, which are known to be produced in copious quantities by combustion, but which themselves are little understood. Additional basic knowledge is needed on how fast detectors must react, what they must be sensitive to, and how they should be placed to be maximally effective. Fire services. As we discussed in detail in Chapter 7, there is room for improvement in the technology of every aspect of firefighting, in the means by which fire departments are notified of fires, in the ways in which men and equipment are dispatched, in firefighters' personal equipment, in the trucks and hoses and suppression agents used to put out fires. State and local pilot programs. To ensure the prompt introduction of research results, a major effort in translating research into operational practice is essential. We envision pilot programs at the state and local level, providing the opportunity for field testing of new research ideas in the real world, serving as a mechanism for demonstrating the practicality of technological innovations to the fire services, and providing training to assist the fire services in their use. Goals for research. Most discussions about fire research focus on particular research problems, rather than on larger questions of what the research can accomplish. Yet, for new initiatives in fire research to be justified, the potentials of fire research ought to be clearly stated. One need only consider the chief causes of fire losses, carelessness and shortcomings of design, to realize that losses could be significantly reduced through research. The National Bureau of Standards has suggested that a 50% reduction in all categories of losses is possible. A more detailed and ambitious set of goals for research would include the following: reduce fires due to human behavior by 80%. Increase in-hospital survival of burn patients by 50% through improved burn care. Decrease firefighter injuries by 50% through better personal protective equipment. Eliminate 90% of all large property losses through improvements in building design. Reduce fire injuries and fatalities at the accident site by 80% through safe fabrics, design of products, detection devices, and on-the-scene care. Increase the fire control capability of fire departments by 50% by faster response and more effective extinguishing methods. These are long-term goals which, in the absence of major breakthroughs or absence of implementation, might never be attained, but they are guideposts for action. It is relevant to note that if the United States had undertaken its space program with the idea, "we might get to the moon," instead of "we will land men on the moon," That event would probably still lie far in the future. The federal role in research. With annual allocations of about $27 million, the federal government accounts for 1/4 of the nation's expenditures on research related to fire. There are kinds of research it would be inappropriate for the federal government to undertake. The development of specific products should remain in the private sector, as should fire endurance testing of materials and products. It is appropriate for the federal government to undertake research that could lead to new products in the long run, especially when industry can only afford modest research for gradual refinement of its products. Studies on incentives and barriers to innovation, now underway in the National Science Foundation and the National Bureau of Standards, may lead to strategies of government-industry cooperation that could shift to industry a greater share of the research toward long-term improvements. How to encourage innovation among the manufacturers of firefighting and related equipment would be one of the major concerns of the proposed United States Fire Administration. Many areas of research will continue to lie beyond the interest of profit-seeking organizations and hence more likely sponsored by nonprofit foundations, universities, or the federal government. This includes exploratory research into highly unconventional solutions, for which the risks of arriving at a dead end are too great for industry to undertake. It includes basic medical research several steps removed from any new pharmaceutical or other therapeutic development. It includes research to serve the government's own nonprofit ends, such as the pilot studies that should accompany the development of new programs in fire safety education. The federal government has developed strong programs in basic and highly exploratory research concerning fire, notably in the National Bureau of Standards, the National Science Foundation, and the National Institutes of Health. Their programs fill important voids left by research in the private sector. Desirable as it might be from the standpoint of economizing, it is not likely that the private sector could fill the gaps if the programs were diminished in any way. The Commission recommends that the federal government retain and strengthen its programs of fire research for which no non-governmental alternatives exist. This is not to say that all federally sponsored research should be done in-house. Throughout the academic and technological communities, there are excellent research resources, and the turning away of research from defense and aerospace programs provides a great source of expertise to be tapped. There ought to be a clear set of priorities in federally sponsored research. Presently, there is no group in the federal government looking at the total picture of fire research needs, including the physics and chemistry of fire, as well as medical, behavioral, and technological problems, and advising the budget makers on what programs deserve what level of support. This is an important function which the proposed U.S. Fire Administration would perform. As it is now, every agency's research program is, in effect, competing for dollars with every other fire research program. Details of how the U.S. Fire Administration would carry out this function are discussed in the next chapter. Certain important aspects deserve mention here. First, the U.S. Fire Administration would have a system of data collecting, which would serve to guide research priorities. The detailed information it gathered on firefighter injuries, for example, would indicate which injuries happen most often and deserve the most attention, as it would also indicate what must be changed to reduce those injuries. Second, the U.S. Fire Administration would be an important clearinghouse of information for both the public and private sectors. Thus, it would know what research industry was pursuing, and it would also know what research problems are not being pursued and possibly deserve federal attention. It would have the important function of disseminating research information to fire researchers everywhere, so that investigators could benefit quickly from the accomplishments of their colleagues and avoid duplicating each other's work. In these ways would the entire nation's efforts in fire research be strengthened. In the next chapter, we also discuss the allocation of federal resources for various purposes, including research. That analysis calls for a near doubling of the federal research effort. Specifically, the Commission recommends that the federal budget for research connected with fire be increased by $26 million. Our recommendation is based not solely on what federally sponsored research could accomplish in the reduction of fire losses, but also on the importance of research relative to other kinds of efforts to reduce losses. Not a federal responsibility alone. As important as federal research is for combating the nation's fire problems, the responsibility is not solely the government's. Social and legal responsibilities are borne by the private sector as well. For example, car manufacturers are held responsible for defects in design or assembly that can lead to accidents. They are not held accountable, of course, for the stupid or careless actions of drivers. By the same token, the manufacturers of materials that go into the built environment are not responsible for the careless actions that lead to fire accidents. But what happens to those materials as a fire progresses can make the difference between a small loss and a huge one, indeed between life and death. To that extent do manufacturers share in the obligation to make the built environment fire safe. The government can require that manufacturers make materials fire safe, as it has done with certain fabrics and as we have recommended that the Consumer Product Safety Commission do for a whole range of materials and products. But industry should accept its responsibilities in the absence of coercion. Accordingly, the Commission recommends that associations of material and product manufacturers encourage their member companies to sponsor research directed toward improving the fire safety of the built environment. People tend to think of research as an expendable luxury, an activity that can be cut off when today's problems, rather than tomorrow's, cry out for solution and total consumption of monetary resources. Behind this view, there sometimes lies resentment that, in supporting research, society pays well-educated men and women to do what they enjoy doing, purely for their own satisfaction. The view is extremely short-sighted. Many of today's problems could be quickly solved or averted altogether if yesterday there had been an adequate investment in research. For many years, there was an underinvestment in research to develop pollution-free automobile engines, and now the nation is forced to a headlong rush, expensive and laden with problems, to develop those engines in time to meet federal deadlines. Likewise, problems for tomorrow can be staved off through adequate investments in research today. There is hope of arresting the so-called energy crisis through research on alternative, untapped sources of energy. Through progress in medicine, automobile design, and pollution control, Americans are fighting against their destroyers. Someday, they will awaken to the realization that they need not accept destructive fire passively. Research must go forward now so that when that day arrives, effective countermeasures against fire will be ready. Indeed, there are already many Americans who do not accept destructive fire passively. They would have welcomed tomorrow's research accomplishments many years ago.